Okay, guys, so this week we're going to be talking about geometric sequences. Last week we talked about arithmetic, and this week is going to be geometric. Don't worry about the series portion. We're just going to focus on sequences for now. So, without further ado, so the big idea is that arithmetic sequences, or arithmetic, however you want to pronounce it, which was last week, is when you're adding / subtracting. So the common difference, or the number that like is hopping in between, like you use to hop in between each number, you're adding or subtracting that number. Geometric is when you're multiplying or dividing. Okay, so very, very similar concept, except the pattern here, there's a multiplication or a division happening between every term. Okay? So in regular words, what is a geometric sequence? It's literally just a list of numbers where we either multiply or divide the same integer, it could be a fraction, to get the next number in the list. Okay, so actually it's not integer. It can be a rational number. So any number that looks like a fraction. Okay, so it's just a list of numbers and we're looking for the pattern. That's literally what we're doing. This is very important. Make sure you get all of this. So the geometric sequence has a common ratio. That is like the same thing, like common difference for arithmetic. The geometric sequence has a common ratio. And just like difference is written as D, like shorthand D, like lowercase d, the common ratio, it is denoted by lowercase r. So formula for the nth term, this is the magic formula. So the nth term is equal to A1, which is the first term. Sometimes they just leave it as A, and then they just, that little 1 that they didn't put there, it's implied, but that 1 is there. So it's the first term of the sequence times the common ratio, and the common ratio is raised to the n minus 1 power. And we're going to do some examples. So this is very, very important. Make sure you have all of this. Let me make sure. I don't need series. Okay. So now I'm going to hop to the book, textbook. So let's see here. I'm going to start. Why can't... Hold on. Technical difficulties. Why are you doing that? What the heck? What is going on? I'm sorry, guys. Hold on 1 second. It is acting up. Okay. Alright, here we go. Okay, so, finally. So, so dividing or multiplying, like we said. This is just how to find the common ratio. You just divide the one term by the term before it. So say if you have this sequence, you can, if you can't like automatically tell what they're multiplying by, you can just divide 10, any number by the number that came before it. So 50 divided by 5, which is also equal to 250 divided by 50. So I just take whatever term I want and I divide by the term that came before it. And they can also be positive or negative. R can be positive, R can be negative. If I would circle that correctly. And so now let's get into like the nitty gritty. You don't need to know the geometric mean. We already wrote this down, but here it is again. I want you to go ahead and copy this example. So make sure you literally have like everything. So just take a minute, pause the video, write it down. Questions and the answers. So let's talk about it. I'm assuming you've written it down. So let's read it and solve it together. We'll talk about it together. Consider the sequence 8, 4, 2, 1, 1/2, and then it just keeps on going. Let me make this a little thinner. Show that the sequence is geometric. So A is asking us to show that the sequence is. In other words, it's asking us, does a common ratio exist? And if it does exist, what is it? So this process of choosing any term and then dividing by the term that came before it, this is what they're doing here, 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 and here. You can see they get 1/2 every single time. So then the ratio would be 1/2. So you can also think of it as them dividing by 2, but we want to talk about this. Okay, let me say it in a certain way. This and this multiplying by 1/2 and dividing by 2. Everybody knows they're the same thing. So, but we want the number that we use when we multiply. Okay? We don't want the number that we use when we have to divide. So they're both correct in terms of how to get the next term, but in terms of how to write the common ratio, we need the number that we use to multiply. Okay? So, let's keep going. We figured out what A was. B says to find the general term. So now we're just going to, this is the formula they gave us. And zoom in. Right, so let me rewrite the fact that, you make that thin. Okay, so the fact that, God. Okay, finally. So let's rewrite that. R is equal to 1/2. This is the formula, the geometric formula. This is the magic formula. Remember that U1 is the first term. Algebraic. Arithmetic or geometric. U sub 1 is always known as the first term. And they want to know what the general formula is. So we know what the first term is. It is 8. Right? Where is it? All the way up here. Yeah, 8 right there. And now we also know what R is, 1/2. And then this just stays just like that. So that is actually your final answer. Okay. And then part C. I don't like that. And then part C, they want to know what the 12th term is. So, using the formula we just came up with, which is... Oops. Let me... Which is UN equals U1 times R to the n minus 1. So we said that UN was 8, 1/2, n minus 1. But in this scenario, n is 12. So now we're just going to plug n in for 12, and then we're going to solve. Okay. I'm sorry. Oh, hold on a second. Okay, so do you see how they literally just plugged it in? Wherever they saw R, they just plugged it in, and then we know what that is. So U12 equals 8, 1/2 to 12 minus 1, which is 11. And then that is your final answer. Okay. So let me talk about a couple more examples before do I want to talk about that one? No. Yes, I want to talk about one of these. So make sure, pause here, write it down. Everything from top to bottom. And I'm going to discuss in a second. Okay. Got thirsty. Okay, so a geometric sequence has the second term equal to -6 and the fifth term equal to 162. It wants to know the general term. In other words, it wants to know what U sub n is. So we know this. The second term equals -6. And then the fifth term equals 162. So notice how they wrote the information that was provided to us. So do you remember how last week I manipulated the information that was provided to me using algebra so that I could use it, so that I could utilize the information they gave me in the form, because the form that they gave it to me in, it was totally useless. So that's what they're doing here again. So they just rewrote, so that's the second term. Hold on a second. So look at how they wrote. So it's always the term that came before it. So that's the second term. They wrote it in terms of the first term times R. And we don't know what R is yet. We don't even know what the first term is yet. But this form I prefer more. And same thing here. That's the fifth term they provided. So I'm sorry. Can't see it. There we go. Excuse me. Here they rewrote it in terms of the first term times, let me write it again, u1r to the fourth equals 162. And the way they got this number was they subtracted 1 from the original, like this number here. That is how they got that number. Okay, so now that we know okay, now let's talk about what they did. They divided to figure out the common ratio. So they took u1 times r to the fourth divided by u1r. You can put r to the 1 if you want. u1 to the r, u1r, which is 162 divided by -6. So this is where your laws of exponents come into play. So ugly. That gets canceled. The u sub 1 gets canceled. So it becomes r4 over r1, which is r3 because we subtract, because we're dividing here. So that's r to the third equals negative, they just divided here as well, equals negative 27. They took the cube root here, and they said, okay, well, what times what times what gives me negative 27? The answer is negative 3. So the common ratio is negative 3. So very fancy footwork here. And so then at the very last step, they said, okay, well, wait, what's the general formula again? So it's u sub 1 times r to the n minus 1. This is the general formula. Now I know what my... Wait. I haven't figured that out yet. I know what my r is. I just need to figure out what my u1 is. And so they use this formula here in the red at the top. Okay, now I know what my r is. And I know what this is. So then they solved for u sub 1. And they came up with 2. And so now I know what the u sub 1 is. I know what r is. And so u sub 1 equals the first term, 2n, times the common ratio, which is negative 3 to the n minus 1. Well, that is ugly. So this is, oh my god. This is your final answer, the general formula. Okay, I know it's kind of weird. Let me see if I can find another good example. I don't like those. I don't want to talk about those. Okay, let's do an example on the Okay, here we go. Example. Ooh. Why? Why are you doing this to me? Okay, example. Geometric sequence. So guys, one of the harder types of problems is given two random terms and then having to figure out the ratio and then the first term. Those are honestly like the harder kinds of problems. So we're gonna start easy. So let's see here. I have a sequence. Show that the sequence. Actually, no. Let me write the sequence. 5, 10, 20, 40, and it keeps going. This is my sequence in the red box. So question 1. Show the sequence is geometric. In other words, does a common ratio exist? And then if it does exist, what is it? So to me, I can kind of just look at it and just tell it is, number 1, it is increasing. It is all positive. Okay, to me, it's definitely getting multiplied by 2. So the way we show it is we just divide every term by the term that comes before it. Like this. So the sequence is 5, 10, 20, 40. So 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So then R equals 2. Okay. Next question. It tells me, using this sequence, it tells me to find the general formula. 5, 10, 20, 40. Question 2. It tells me to find U sub n, otherwise known as the general formula. If you guys remember from your notes, very straightforward. That's the general formula. Do I know the first term? Yes, I do. So the first term is 5. And I actually just found the common ratio, which is positive 2. So I can just put them together to get the general formula, which is 5, 2 to the n minus 1. And you want to leave it like this, mainly because this is not equal to 10 to the n minus 1. These are very different things. The n minus 1 is attached only to the 2. It is not attached to the 5. So that's why you do not want to multiply. You do not want to multiply. Okay, so let me rewrite that. Oops. Alrighty, and last part, it tells me to find the 15th term. So question 3, using this sequence, find u sub 15, also known as the 15th term. Okay, so n at this point is equal to 15. So now we're just going to plug it in. So using this formula, u sub 15 equals 5 parentheses 2, 15 minus 1, which is rewritten u to the 15 equals, that's ugly, 5 parentheses 2 to the 14th power. And at this point, you would just use a calculator. Oopsie. So u15 equals, what was it? 5 times 2 to the 14th. Which is what? Sorry guys, give me a second. Calculator just died on me. Two raised to the 14th. Okay, so 2 raised to the 14th equals 16384. So 5 times 16384 equals 81920. This is our final answer. Okay, so make sure you have that. We're going to do one more problem now. It's going to be similar to the second example. All right, let's see here. So it says find the general term of the sequence which has, alrighty, find, this is a new example. So general term just means u sub n. Or you just use the formula of the geometric sequence which has u sub 4. So the 4th term, that's the 4th term. 24. And then the 7th term which is, rewrite that just so it matches. $192. Okay, so they gave us two like weird values. They gave us the 4th term and then they gave us the 7th term. And I need to know, pretty much, they're telling me to find u sub n, which is u1 times r to the n minus 1. That is what they're telling me to find. In other words, fill out the formula. And so the first thing we're going to do is we're going to rewrite the information that they provided to us into a format that I can manipulate, okay, using algebra. So they said the 4th term was 24, but that's really just the 1st term times r times r times r to get the 4th term, right? So in other words, that's u1 to the r times r to the 3rd okay, we're going to do that again with the 7th term. So u7, which is 192, it's really whatever the 1st term is times r, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6 times. It's 1st term, 2nd term, 3rd, 4th, 5th, 6th to get the 7th term. So u1 times r to the 6th. Here I'm just explaining why this is 6, right, and why this is 3. But if you just want to remember it, just subtract 1 from the term number that they provide. It's easy to do that. So 192 is equal to that. So now what we're going to do, we're going to take these two pieces of information and we're going to manipulate them even further. We're going to pit them against each other. So this is what we're going to do. Oopsie. Can I go more down? No. Okay. So then 192 over 24 is equal to u to the 1st power r to the 6 over u to the u sub 1 r 3. Is that right? Yes. So we're going to divide now. 192 divided by 24. That is 8. And now we're going to simplify the right-hand side. So that's R6 over R3. So 8 is equal to R3. We subtract the exponents now. I want to know what R is. I don't want to know what R cubed is. So I'm going to take the cube root of both sides and so the left-hand side becomes R because they cancel each other out. So what times what gives me 8? Ladies and gentlemen, the answer is 2. 2 times 2 times 2 equals 8. And so I figured out my R. My R is 2. And so now what I'm going to do is I'm going to go back. and I'm going to show you what I'm going to do. I'm going to use this equation in the black box. So 24 equals u sub 1 times r cubed. Ooh. Oh my gosh. So 24 equals u sub 1 times r cubed. But now I know what r cubed is. Divide by 8. That cancels. That becomes a 3. So my first term is 3. So I figured out my r. I figured out my first term. And so now I'm going to put it all together for the general formula. Oopsie. Well, yeah, you can write it like that. And then my r is, what did I say my r was? My r was 2. 2, let me do it in black. And minus 1. Also known as I like that better. And there you guys have it. So that's the end of the video. I hope you guys liked it. I hope it helps you. Please email me if you guys have more questions. Please also show up if you have more questions to the live lesson tomorrow. The topics are only going to get more complicated, so do not fall behind, please. Obviously, I am here whenever you need me, and I will see you guys next week. Okay, bye-bye.